Hi, welcome to Module 2 of the second week of college algebra. This course, like I said, goes by quickly. Okay, this week we're going to focus mainly on quadratic functions, equations, and we're also going to focus on an introduction to functions and an idea called piecewise defined functions. So I'm sending you out a document. We're going to start covering that in video like we did last week. So our first session is going to mainly focus on solving quadratic equations. We're going to focus two different ways, actually three different ways. And then there's a fourth way that we're going to look at a little later called completing the square. Completing the square essentially is where the quadratic formula, which is one of the things we're going to cover today, comes from. But in the meantime, let's take a look. All right, so in this week's document that I'm sharing right now, you should see that. In this week's document, what we have is earlier we have some, and I'm not going to go over those in a video session, but we do have some applications here that you should be aware of, mainly geometric applications. Let's go directly to the quadratic equations. So quadratic equations, and we can solve quadratic equations. One way we can solve them is by factoring. The steps in solving quadratic equations is get the equation in the form ax squared plus bx plus c equals 0. And that's the first thing. Using, sometimes you have to multiply it out. Sometimes you have to, use an addition property to get all the values on one side and 0 on the other. Then we try to factor. If it can be factored, it can be solved with this method. The problem with this method is that not everything can be factored. Once we factor it, we set each factor equal to 0 and solve each individual equation. Then we check our solution. Okay, so for example, suppose we have x squared minus 5x plus 6 equals 0. Step 1 is done. It's already set equal to 0, and it's in that form. Ax squared plus bx plus c, where the a is 1, the b is minus 5, and the c is 6. To factor, we will need two numbers that multiply to be 6 and add up to minus 5. Those two numbers would be minus 2 and minus 3. So we factor it as x minus 2 and x minus 3. Then we set each factor, the x minus 2 equal to 0 would be one of them. And we set the x minus 3 equal to 0, that would be the other, and solve. This gives us x equal 2 and x equal 3. To check, we literally just put in each one at a time into the original equation and see if it equals 0. So putting 2 in, we notice the parentheses, practicing that safe algebra with parentheses. Okay, anytime you make a substitution, you use parentheses. So we have the quantity 2 squared minus 5 times 2 plus 6, which gives us 4 minus 10 plus 6, or 0. And the same thing with the quantity 3 squared minus 5 times 3 plus 6. This would be 9 minus 15 plus 6, which is 0. So they both check out. Sometimes we have to use that AC method we talked about a little bit last week. 3x squared minus 10x minus 8 equals 0. A times c, the 3 times minus 8 is minus 24, and the b is minus 10. So we need two numbers that multiply to be minus 24, and those same two numbers add up to be minus 10. Those two numbers would be minus 12 and 2, because minus 12 times 2 is minus 24, and minus 12 plus 2 is minus 10. So we'll do our rewrite. 3x squared minus 10x minus 8 equals 0 gets rewritten as 3x squared minus 12x plus 2x minus 8 equals 0. We're going to factor this part by grouping. So to do that, the first set of parentheses, I wrap around the 3x and the minus 12x. I can factor a 3x out of that, giving me 3x times the quantity x minus 4. When I wrap 2x minus 8 in parentheses, I can factor a 2 out of that, giving me 2 times the quantity x minus 4 equals 0. The x minus 4s are in both slots here, so that makes it a common factor. So we factor that up. X minus 4 gets factored out. That leaves us behind what we factored out the first time around, the 3x plus the 2. And so then we set each equal to 0 and solve like before. And then we check. Okay. Another technique we could use is the quadratic formula. Now you should be somewhat familiar with the quadratic formula. Okay, we want to get the equation in the form ax squared plus bx plus c equals 0. We also want to have, it's more straightforward. You're going to make less errors with the plus and minus part if a is greater than 0. So try to make a greater than 0, the number in front of x squared, or the squared term. Okay. Once all that takes place, we get x equals minus b, plus and minus the square root of b squared minus 4ac over 2a. And I work out an example here. We have 9x squared plus 3x minus 2 equals 0. So that means a is 9, b is 3, and c is minus 2. So replace we c and a, we put a 9 in. Now again, when we substitute in, we practice that safe algebra, putting it in parentheses. Wherever we see a b, we put a 3 in. Again, that goes in parentheses. And wherever we see the c, there's only one place for the c, we put the minus 2 in. So this gives us minus, and in parentheses, 3 plus and minus square root, and in parentheses 3 squared, minus 4 times, and then in parentheses 9 times, in parentheses minus 2, over 2 times in parentheses 9. Now the most complicated part of this whole process is the square root part. Okay? So I'm going to work under the square root. I get 81, and the square root of 81 is 9. So we have minus, plus and minus 9 over, well, 2 times 9 is 18. So that gives us, for the plus case, 6 over 18, or 1/3. And for the negative case, it'll give us minus 12 over 18, or minus 2/3. And so the third process we want to look at is the, or method rather, we want to look at is the square root method. This is used when we have no bx term, or when we have a scenario where we have a quantity with x inside of it squared plus a constant equals 0. The first thing we do is we isolate the square root term. We do plus and minus square root both sides, isolate the x if needed, and check our answer. So for example, we have minus 3x squared plus 18 equals 0. So we're going to isolate the square term. To do that, we'll subtract 18. Then we'll divide by minus 3. And this gives us x squared equals 6. Then we'll take plus and minus. Don't forget about the minus case. Square root on both sides. The reason the minus case has to exist is because I can square a negative and get something like 6. Or I can square a positive and get 6. Okay. And so when I square root the x squared, the squares and square roots cancel off. On the other side, I still have plus and minus 6. And so then part 3, not needed. X is already isolated. So when we plug into the original equation, we have minus 3 plus and minus in parentheses because we made a substitution, plus and minus square root of 6 squared plus 18 equals 0. Now like up here in this step 2 where square and square root cancel off, it's going to down here in our check step because the square of a square root of 6 just gives us 6, whether it be plus or minus. Remember, a negative square always is positive. Negative number squared is always positive. And so the negative goes away as well. So we have minus 3 times 6 plus 18, or minus 18 plus 18, or 0. In our second example, example B, we have minus 4 times the quantity x minus 4 squared plus 32 equals 0. So we need to isolate the square part. So that would be this x minus 4 quantity squared part, this part right here. And so to do that, we'll first subtract 32 from both sides, giving us minus 4 times the quantity x minus 4 squared equals minus 32. Then we'll divide both sides by minus 4. Minus 32 divided by minus 4 gives us positive 8. Just like before, we will plus and minus square root both sides. In step 2, the square and square root cancel off. In this case, what happens then is we're just left with x minus 4. So x minus 4 is equal to plus and minus the square root of 8. Now, I don't know how much you remember about simplifying radicals, But with the square root of 8, we have a perfect square of 4 times 2. So we'll take the square root of the perfect square of 4. That gives us 2. So that's where the 2 comes from here. And then the square root of 2, well, that's the 2 from the 4 times 2 part. Can't do anything with that. 2 is not a perfect square. And so that gives us plus and minus 2 square root of 2. So now, since this is x minus 4 equals plus and minus 2 square root of 2, we have to isolate the x. To do that, we'll add 4. And so when we add 4, we get 4 plus and minus 2 square root of 2. And you can check this with your calculator. Okay. Now, next time we get together in video, which should be tomorrow, we'll talk about functions and relations. In the meantime, have a good day. I hope this helped you. And make sure you realize that everything today on the 18th is coming due for Module 1. So make sure to finish that up today before the end of the day. Have a good day.